So here some simple rules are there for simplifying this K-map in order to get the standard SOP. So previously we have gone through a standard SOP and standard POS, which are having different steps. Here I'll show you. Okay, this was the steps, step 1 2 3 4, to simplify a sum of product SOP into standard SOP, and also from general POS equation into a standard POS equation. Okay, now instead of going for these steps, we will utilize a kern of maps. Okay, how we are going to do that? First of all, we need to select a particular K map based upon the number of variables. Okay, whether we have a 2 variable inputs, whether we have a 3 variable inputs, 4 or 5 variable inputs. Then we need to go for the min terms. So a Boolean function, if it is given as a sum of min terms form, then we need to place all the ones at respective min term cells. Okay, according to this m0, m1, m2, m3 is there, no? So if we get any output in terms of the m0 to m16 or whatever the number place, that one we have to place in the K map. With an example we will see all these things. First just look at all these steps, then we'll go for with one example so that it will be very easy to solve all these things. Okay, so the third step is if the Boolean function is a sum of products, that is SOP or min term, then place the ones in all possible cells schema which given product terms are valid. Okay, either it may be a SOP or it may be in a POS. If it is SOP, we need to place 1 in the K map. If it is a POS, product of sum, we need to place a 0 in the K maps. Then check for the possibility of grouping maximum numbers of adjacent ones. So it should be powers of 2. So 2 raised to 2, 2 raised to 3, 2 raised to 4. If suppose grouping has to be done, okay, grouping a maximum number, first we need to check that a maximum number. Now what will be the maximum number in a 16? It is a complete 2 raised to 4, then 2 raised to 3, and then 2 raised to 2. So like that we need to group the number of ones. Then each grouping will give either a literal or one product term. Whenever we do a grouping of 2 ones or 4 ones or 8 ones, then each of this group will give us a product term. So this product term is called as prime implicant. Prime implicant. Okay. Then the essential prime implicant is if at least single one is not covered with any other groupings. That is, if one is present but that single cell is not grouping with other cell, so only one is remaining here. If it is not covered with any of other groups, then that we call it as essential prime implicant. Okay, so two terms have come up here. One is prime implicant, another one is essential prime implicant. So prime implicant is what? If we have a group, out of that group we will get one product term. That is prime implicant. We don't have any group, only one is remaining. This one is not sharing a group with anyone. Then also we will get a term, and that term is called as essential prime implicant. Okay, then note down all the prime implicants and also the essential prime implicants. So the simplified Boolean function contains all essential prime implicants and only required prime implicants. This is what the steps. If we follow in a practical way, by taking some examples, you will be understanding it very clearly. Okay, there are two notes are there. Just a simple things. If outputs are not defined, if suppose output is not defined, whether it may be a 0 or it may be a 1, then we have to consider it as don't care symbol. X we have to mention in the X. Okay, either it may be a 0 or it may be a 1, but whenever a don't care term is present, whenever a don't care term is present, then this don't care X is been replaced in a respective cell. Then we can consider this don't care to help. It is helpful for us in a grouping of maximum number of adjacent ones. Okay, in those cases, treat the don't care value as a 1. So if you want to make a groupings, maximum number of groupings, and if you are not getting 1, then we can consider X only as a value 1, then we can include this X into the group. Hopefully, I don't know whether you understood this theory or not, but when we go for example with a practical here, then it will be very easy to understand. Okay. One more thing, I think I'm not hearing any voice from your side. Whatever the thing you want to convey to me, you just write it in the chat box. Okay. Right. Now we'll take one example. So consider a Boolean function here. What is a Boolean function is present here? F equal to summation of m of 0, 1, 2. Okay, this is one simple function. Boolean function is been given. Now I don't know what will be the output for this. So for that purpose, what I have to do? What do you mean by this? Summation of m of 0, 1 to 3 is nothing but f equal to m of m0 plus m1 plus m2. Okay. Another important point is now whatever we are discussing, it is all in terms of min terms, sum of products. The product of sum is same but opposite of this SOP is also having the same procedure but only opposite of SOP. POS is opposite of SOP. Okay. So here we have taken all the examples of minterms, that is SOP form only. Then we will, whenever we minimize all these things, then it will be a standard SOP. Okay, but we are maintaining, we are following a K-map methodology to solve a general SOP into standard SOP. So here what we have got, F equal to M0 plus M1 plus M2. Right. So if I want to write a truth table for this, if I go for this, how many terms are there? 3 terms are there, right? So for this, I am going to take two variables. Okay, two variables are there, whereas A and B, I have took it as A and B. Now, what are the inputs that A and B are going to be varying? 0, 0, 0, 1, 1, 0, and 1, 1. Okay. So now, what is F M0? So what is here? What I have to write? M0 as a 1. Okay. M0 as 1. Then m1, m1 is there, so I will write 1 in place of m1. M2 is also there, I'll write 1 in terms of m2. And there is no m3, that is why I am putting it as 0. Okay, if suppose this was a POS form, m0 dot m0 dot m1 dot m2, then I would have placed 0, 0, 0 and 1. Okay, that is only the difference between the SOP and POS. Okay, but however, we are not going for the uh, POS product of terms here. We will take examples on product of terms also. But first, if we are clear with SOP, then it is very easy to write, deal with POS. Okay. So here, so this is what a truth table I have written. I have extracted from this function. Okay. Then what I will do, the K-map is shown in figure. Okay, the essence of K-map is is just a two-dimensional, that is two variable here. What is the input? How many? It is a two inputs. So now here what we will do, we will take a two-dimensional or two variable representation of the input. Either it may go in what you can say. Okay, only the, I think only square thing I will get, square representation I will get here. Right. This is the only representation that I will get from two variable. So now here A I have written, B I have written. Okay. Now A is 0, 1, 0, 1. So let us see that the intersection of the first row and the first column is 0, 0. Correct? What is 0, 0? It is 1. So what I am writing here, I am going to write it as 1. Then the intersection of this, the intersection of first row and second column. What is that? The input A is 0, B is 1. A is 0 here. What is the input? A is 0, B is 1. What is the output? It is also 1. So what I am going to write here? 1. Then the intersection of the row 2 and column 1. Here also I have got for 1 and 0, I have got the output 1. So I will write here as 1. Then the intersection of row 1 and column 1. Sorry, column 2. So here I have the output as 0. So I'm writing it as 0 here. Okay. Now I have just written a K-map. Right? For two variables, I have written a K-map. How to make a groupings in this? So in the previously in the steps we have seen that make a maximum number of groups. Okay, whereas it should be in terms of 2 raised to n, powers of n. Now 2 raised to, how many input variables are there? 2 are there. 2 raised to 2 is going to be 4. Whether I have a 4 number of ones? No, I don't have a 4 number of ones here. I have 3 number of ones here. But I cannot make a group of 3 numbers. What is a lesser than 4? It is going to be a 2. So that is why it is going to be a powers of 2, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 4, 2 raised to 5. So like this, I have to make a groups. Okay, right now, what is the maximum number I will get from these two variables is 4. But here I don't have a number of ones. I don't have 4 number of ones. That is why I cannot make a group of 1. One group of 4 numbers I cannot do. Then what I can do? What is the lesser than 4? It is 2. 2 raised to 1 is 2. Okay. So now whether I have a number of ones to how many groups I have here when I want to make a group of number of ones. Now here this is one group I have. They are adjacent to each other, so that is why I can make a group of ones here. And how many number of ones are there? It is 2. 2 number of ones are there. Now I can make a group from this. Now here when I make a group, what is the solution I'm going to get here? Okay, that I will tell you later. Now, another, can I make another group from this table, from this K-map? Yes, that in the first row, there are 2 intersections, 0, 0, 0, 1. So here also I have one group. Here also I have one group. Okay, so now I have made 2 groups here. Whereas what, let us see the first group here. From this group, what are the output that I am going to get? Now here for this first row and second row, A is going to be 0 and 1. A is going to be 0 and 1. So A, one time A is going to be 0 and another time A is going to be 1. So it is not constant. 1 into 0 will remain it as 0 only. Then see, that is what I have got here is A plus A bar. A is there. This is one term plus, sorry, A bar is there plus A is there. For this multiplication with 0. 0 is nothing but B bar. Okay. So due to this A plus A bar, what is this condition? A plus A bar is going to be 1. Yes. Okay. So A plus A bar is 1. 1 into B bar, what I am going to get is only B bar. So from this group, I am getting only B bar. How about this group? Here A is common, B is varying. What is A here? A bar. Okay, we know that in a min terms, 0 is considered as complement, 1 is as it is. Okay, so A bar is there. For this, A bar is there. A bar is common and B is going to be varied. B bar plus B. Okay. But what is B plus B bar? It is 1. So 1 into A bar, what I will get? A bar. Okay. So how many terms I have got from this whole table? It is A bar plus B bar. So this function this function will give me equal to a bar plus b bar. The output of this function is a bar plus b bar. Okay, so let us take some examples. A bar plus b bar. First insert this 0 0. What will happen? 0 bar plus 0 bar. What is output? 1. Okay, then 0 bar plus 1 bar. So what is it? What I will get? I'll get 1. Again 1 bar and 0 bar. I will get 1, and then 1 bar plus 1 bar equals to 0. Okay, so here I will get 0 plus 0 equals to 0. Right? So the truth table has been simplified in terms of standard SOP now. Okay, if I have gone directly for writing SOP, what I will get here? It is a bar into b bar. Here what I will get? A bar b. Here a b bar, and here a b. Okay, no, I will not take this. So what is the function here? What is the function here? A bar b bar plus a bar b plus a b bar. Okay, now this is the function. This is the function that I am going to get from this truth table. A simple general equation, SOP form. Okay, but when I put a K map for this truth table, and then I follow all these steps, then what I have got? F equal to a bar plus b bar. F equal to a bar plus b bar. So this is also same, this is also same, but the only thing is this is quite complex to implement in terms of logic gates. I require AND gate, OR gate, NOT gate. How many? I require 3 AND gates here. Okay. But here I don't require any NAND gate, AND gate, but I require only OR gate and NOT gate. And that too only two NOT gate plus one OR gate is sufficient to implement the whole equation. Okay, so it is very easy to implement through that is by solving through a K map. Now this is a standard SOP. Okay, this is a normal SOP, sum of products from this truth table that we have generated, and this is standard SOP through what? Through K map. Hope you have understood this. Okay, so here this is the one group that we have got out of all these three things, and at the end we have got F equal to a bar plus b bar, and it is very easy to implement this. How I will implement? I'll take one NOT gate here. and one more not gate. This is A, this is B, then one OR gate. This is F. So this complete truth table, instead of going for this general equation of SOP, we have solved it in the very easy step by using a K-map, and that we have got A bar plus B bar, and we have put a implementation of this function in the by using the logic gates. That is so simple, and this is simple as we have gone for only two variables. Okay, now let us go for three or four variables. Okay, let us take an example of four variables. So let us simplify the following Boolean function f of w x y z. Okay, using K-map. Now instead of going for this function m0, m1, m2, we have already been provided with the truth table here. Okay, so the truth table is already available here. Then what are the min terms? If I go for a general SOP, what are the min terms that I will get from this truth table? Here I have one. Okay, don't go for a max term. Max term is when we'll go by considering zero value. For min term, we are going to take value 1. Okay, now understand min term. The max term is simple. So what I'll get here? W bar, X bar, Y, and Z bar. Then I'll not write here. So here W bar, X, Y,
X, Y,
Z bar.
Z.
And here W, X bar, Y bar, Z
Y
bar.
bar, Z bar.
Then here W, X bar, Y bar, and
Y bar,
Z.
Z.
Now here W, X bar,
X bar,
Y,
Y,
bar,
Z.
and here it is W, X bar, Y, Z. Now here W, X, Y,
W,
Z bar, and W,
Z bar.
Y.
W, X, Y, Z.
So this is a general equation I will get. How I have to write this? Now F equal to this one plus this one plus this one okay. See, it is very much lengthy here. If I want to write a general equation of sum of products, it is very much lengthy to implement in terms of logical gates. Okay, now what I will do by taking this once, I am going to write a K-map. First step is K-map. Now how many variables I have? I have 4 variables. For 4 variable K-map, how I can write it? So Wx, Yz. Either on the left side, you can change it however you want. If you want to change it, okay, you can write Wx upper side, Yz lower side, or Wx lower side, Yz upper side. Okay, now here it is being taken it as Wx lower side, Yz upper side. Now, what is the combination of Wx? It is going to be 0, 0, 0, 1, 1 1 1 0, and this one we have discussed yesterday. Okay, 1 1. Then yz is going to be yz 0 0 0 1 1 1 1 0. Now write it as, now where I have, this is the first term I have as a 1. What is this? W bar, that is Wx is 0 0 and this is 1 0. See here, 0 0 1 0. The first row is 0 0 and the last column is 1 0. So the intersection of this 0 0 1 0 is first row, last column. Here I am going to write it as 1. Okay, then what I have next? W bar x y z bar. Here I have 1. What is the input? 0 1 and 1 0. Now here 0 1 0 1 1 0. 0 1 is there, wx is 0 1, and where is 1 0? Again here the fourth column, second row, fourth column. Here I'm going to write 1. So like that I have, here I have 0, sorry, 1 1 1 1. Okay, now this 1 0 0 0, where it is 1 0 0 0, 1 0 1 0 is fourth row, 0 0 is first column. Okay, so here I am going to write it as 1. So wherever these ones are present, like the last one, 1 1 1 1, so third row and third column, here I am going to write 1. This one, this one I have written here, 1 1 1 1. Okay, then this one, double on 1 0. So this is double 1 and 1 0 is here, this one. Okay, this is how I am going to write. I think the session may stop now. We will restart the session and we will finish this four variable. Okay, how we can solve this for, we will see how we can solve this four variable, and then we will end up the class, or else okay, right now just we have seen how to write a KMF for this all ones, for this truth table. Solving we will see in the next class. Okay, the grouping of these ones and then solving of these ones we will see in the next class.